Hey everyone, and welcome. Today, we're going to dive into one of the most foundational, most powerful programming languages on the entire planet, Java. So whether you're just kicking off your coding journey, or maybe you're just looking for a quick refresher, you are absolutely in the right place.
But before we get into the nuts and bolts, let me just ask you a question. What's that invisible force that's humming behind the scenes of your favorite Android app, or that keeps your online banking secure, or even powers huge chunks of the cloud? Yep, you guessed it. The answer is Java. And today, we're going to see exactly how it does it all. So here's our game plan. We're going to build our understanding from the ground up. First, we'll talk about the one big idea that really put Java on the map. Then, we'll open up the developer's toolkit to see what's inside. After that, we'll get into the basic grammar, learn how to write some rules for our program, and finally, we'll get our heads around the core design idea of Java before we see where it's making an impact in our world today.
All right, so first things first. Let's explore the one concept that made Java an absolute global phenomenon, its Run Anywhere promise. This was, and still is, a revolutionary idea.
So picture this. It's the early 90s. A team at Sun Microsystems, led by a guy named James Gosling, had a huge problem. See, the world was filled with all these different devices. You had computers, sure, but also early smart gadgets and all sorts of electronics. And writing software for each one was a total nightmare. So their goal was to create one single language that could run on all of them without being completely rewritten every single time. And that project, which started out as Oak, eventually became Java, and it exploded onto the scene, becoming a powerhouse for the new thing called the Internet.
And this was its killer slogan, write once, run anywhere. Now what this meant, and this is the key, is that a developer could write their code on, say, a Windows PC, and that exact same code would run perfectly on a Mac or on a Linux machine or on any other system without changing a thing. This idea of platform independence was an absolute game changer.
So, how in the world does Java actually pull this off? Well, to understand that, we need to pop the hood and look at its essential toolkit. Let's think of it like setting up a complete workshop, with all the machinery and tools you need to build something amazing. Okay, first up is the JDK, the Java Development Kit. This is the master toolbox. If you want to create a Java program, to actually build something from scratch, you need the JDK. It's got the compiler, the debugger, literally all the tools of the trade.
Next, you've got the JRE, which stands for the Java Runtime Environment. Now, if the JDK is your personal set of tools, the JRE is kind of like the finished workshop space itself. It's the environment that a finished program needs to actually run. See, the average person using your app doesn't need all your hammers and saws. They just need the clean, powered-up space to make it work.
And right in the heart of that workshop is the master craftsman, the real magic maker, the JVM, or the Java Virtual Machine. This thing is the secret sauce behind that whole Run Anywhere promise. It acts like a universal translator. It takes this generic compiled Java code and, right there on the spot, translates it into the specific language that your computer, whether it's a Mac, a PC, whatever, can actually understand.
Okay, so let's connect the dots here. You, the developer, you write your code in a plain text file ending in .java. Then, the JDK's compiler takes that and turns it into this intermediate language called bytecode, which gets saved in a .class file. Then, the JRE provides the whole environment needed for it to run, and finally, that JVM inside the JRE translates and runs that bytecode on your machine. Simple as that.
All right, so we've got our workshop set up and we understand the workflow. Now it's time to actually look at the raw materials we're going to be building with, the real nuts and bolts of the Java language itself.
In any building project, you got to know what you're working with, right? Are you using wood, steel, or glass? Well, in Java, we call these data types. You've got your basic or primitive types like int for whole numbers or boolean for a simple true or false. And then you have more complex, non-primitive types like string, which is what you use for handling text.
So where do you put all this stuff? Well, that's where variables come in. A variable is really just a named box in the computer's memory. So in this example, we're creating a box called age. We're telling Java it can only ever hold an integer, int, and then we're putting the number 20 inside it. That's it.
Okay, workshop? Check. Materials? Check. Now we need the assembly instructions, the actual rules that tell our program what to do and when to do it.
So take a look at this. This is about as simple as a Java program gets. That public class main line, that's just the main container for the whole program. Now inside of that, the main method is super special. It's the official starting point.
It's the exact spot where Java begins to run the code. And this line right here, system.out.println, that's just the instruction that tells the computer to print hello Java onto the screen.
But let's be real, programs get really interesting when they can think for themselves, right? And that's where control flow comes in. You need to check if a user is old enough. That's a perfect job for an if-else statement. You need to do something for every single item in a list. A for loop is your best friend. These tools let our programs react and make choices instead of just running down a dumb list of commands.
Okay, now we're getting to the big one, the absolute heart of Java, what's called object-oriented programming. If you can get your head around this, you really understand Java. And the best way to think about it is like creating a master blueprint for everything you want to build.
So here's the key distinction. A class is the blueprint. It defines what a house is in general. It says a house has properties like a number of windows, and it has behaviors like open the front door. But an object is the actual building you make from that blueprint. So your house at 123 Main Street and your neighbor's house next door, they're two different objects, but they were both built from that same house blueprint.
So how do you actually make a building from that blueprint? You use a special little method called a constructor. Just think of it like the construction foreman on a job site. The second you decide you want to create a new house object, the constructor is the first one on the job. It gets to work setting everything up, initializing all its properties, making sure it's ready to go.
All right, we've looked at the tools, we've seen the materials, we've even studied the blueprints. So now let's zoom out a bit and just appreciate the massive, real-world skyscrapers that have been built with Java.
So, remember that question I asked at the very beginning? Java is the absolute backbone of the Android operating system, running on billions and billions of devices. It powers the super secure, massive-scale systems for the world's biggest banks and e-commerce sites. It's a huge player in cloud computing, and it runs the application servers for countless websites you probably use every single day. It is, and I'm not exaggerating, literally everywhere.
So really, the big takeaway here is this. Java isn't just another programming language. It's a super robust, secure, and battle-tested ecosystem that really did help build the digital world that we all live in today. The foundation is there. The only question left is, what are you going to build with it?